Once again, it's time for another machine building basics video, and this time we're going to talk about cables and cable management. Let's go! So, this time I don't have that many things to show you. Because, well, what's that interesting about showing different color cables? But there are some different versions we're going to talk about, and the reason to use one or another. But first, let's talk about one of the most important things when it comes to cables in machines. And that is cable management. Now, I'm not an expert, not by any means. And just to show you that I'm telling the truth, here is the cabinet of my CNC machine. And while it's not too bad, it could be a lot better. Now, this is one of the downsides of putting everything in a slightly too small cabinet. But let me show you some really bad examples I've had at work. After that, I bet you think my electrical cabinet is looking quite good. But anyway, there are a few main reasons to be particular about how you manage your cables. And two of the most important ones are that a well-managed electrical cabinet is a lot easier to troubleshoot. And trust me, sooner or later you are going to need to troubleshoot your machine. Or someone else's machine. That's basically one of the main things I do at work. And let me tell you, trying to troubleshoot a 30-year-old machine with a horrible electrical cabinet and quite often non-existent or wrong electrical documentation, that's quite a handful. Now, another one of the most important things about cable management is that proper cable management minimizes the risk of interference. And interference in this case is interference from high power sources on your signaling cables usually. So let's say a CNC spindle or a servo motor. And the high power cables, especially high frequency cables like from a VFD, they will cause interference and parasitic currents in your signal wires. And if you're using a low voltage system, like we are here using a 5-volt system on my Queen Bee Pro CNC, then actually having interference cause false triggering of the end stops, for example, unless you manage your cables properly and use the right type of cable. Now, here in Europe, we have something called the Machinery Directive, and that is basically standard, telling machine builders how to build a machine, or how to build a machine that conforms to both CE norms and other associated norms. Now, within the Machinery Directive, there are of course a whole bunch of information that if you're building a machine to sell it to someone, you need to know about. But here are some important bullet points that I think you should know if you want to build your own machine, or if you in the future want to build machines and sell them, or work for someone that builds machines. So first of all internal cables should have individual numbers. And this means that every single wire going from one terminal to another should have an individual number, usually between 3 and 5 numbers. So your first wire might be named 100, then we have 101, 102, 103, and all the way up an individual number for every single wire. And a wire is defined as going between 2 terminals. Now on many American machines, you don't need individual numbers on all the cables. Let's say you have a power feed, for example. Let's take this one. Now this black cable here starts at this terminal, is a jumper to this terminal, and then over to this terminal. Now in Europe, this cable would have one number, this cable would have one number, and this cable would have a third number. In the States, all of these 3 cables would have the same number, since electrically speaking, they are the same cable. This terminal will have exactly the same potential as this one. And in my mind, that can actually make troubleshooting easier. Because you know, if you have a power feed named 100, you will never have to look up what cable 103 means. And see that that one connects to cable 102. That connects to cable 100, or 101, sorry. I misnumbered it, but you get the meaning. Now, if we're doing it the American way, you know that this cable is a power feed because it's named 100, the same as the incoming power. And that means that in many cases you can troubleshoot an electrical cabinet without having an electrical schematic. Now, not so much in Europe. You need both the electrical diagram and also a sheet telling you all the individual cable numbers and between which 2 terminals they go. Now, all external cables should be marked with both starting point and termination point. And external cables are all the cables that go from your electrical cabinet and to peripheral equipment. And In our case here, that might be these end-stop switches, it might be these buttons, it might be this secondary electrical enclosure, it might be the spindle, it might be anything that is outside the main electrical cabinet. And a quite common form to write this is that you have first a component designation, that would be the number of the end-stop switch, for example. Then you have the terminal number on the end-stop switch. On my case here over on the CNC, that would be terminal 1 or 2. And on the other end, you would then have the cabinet designation. So if your main cabinet is called H001 or P001 or something similar, then the terminal designation, if you have several different terminal strips inside the cabinet, that would be maybe X1 or X2. And then the terminal number, so input 25 on terminal X2 in cabinet P001, for example. And quite often different suppliers have different ways of fulfilling the standard, so these might differ quite a bit between different manufacturers. And that's just something to be aware of and work with. And today you don't have to do this manually, as you had to before. Almost all electrical CAD software that I know of does this automatically. So you build up the entire electrical system, and the CAD software spits out all the item designations based on your chosen format. Within the machinery directive, there is a part called EN 60204, and that is machine safety, subsection machines electrical equipment. And in there, we get a list of colors we can use for control wires and power wires within electrical cabinets. And here's a list: black, brown, red, orange, yellow, green, blue, purple, gray, white, pink, and turquoise. Whew, that was a mouthful. Or combinations thereof. And combinations thereof is quite important, because you might have a cable with 20 or 25 or even 30 individual wires inside of it, and each one of those will need to be either numbered or color-coded. Now, usually they are numbered from 1 to 25 or whatever, but on some wires, especially smaller wires that would be so small you couldn't see the actual number, they are color-coded instead. So they might be brown with red stripes or orange with green dots, and those can be really hard to keep track of sometimes. Now, one important thing to note here concerning the different types of combined colors is that yellow and green cable is not to be used when there is a risk of confusing it with protective earth, because cables that are marked in yellow and green are only to be used for protective earth and nothing else. So if you open an electrical cabinet, you should know that the yellow and green cable is always connected to ground. And in the same way, blue or preferably light blue is to be used for neutral, but they can also be used for other functions in case it cannot be confused with anything else. Now, in quite many electrical cabinets I've been in, light blue is used only for neutral and dark blue is used for other signaling cables. But like I said, they can be used for signaling as well, as long as that it can't be confused with anything else. Now, there are of course recommendations on what colors to use, and there will be a list on screen here as well, and that is basically that black should be used for power feeds, AC or DC. Red should be control and signal wires when you're using an AC current. Blue should be control and signal wires using DC current, like I said, preferably dark blue. And orange should be foreign current that is not broken by the main power breaker. And using orange cabling is quite common when one section, or maybe the entire cabinet, is fed by a UPS power supply. Because then you should know that even if the main power breaker of this cabinet is off, you will still have power running through it. And the same way, if you have a power outage, orange wires might still have full power on them until the battery runs out of the UPS. And if you're observant, you can see here that I have followed this standard when I chose the different colors of the cables in this cabinet. So here we have AC control wire, that is my start and stop switch. I have blue signal wires. I have blue ground, or I should say light blue ground and dark blue signal wires. I have black power feed on the AC lines. Here is one position where I didn't use light blue because I didn't have a thick enough cable in light blue for neutral, but that blue cable is neutral. And of course black for the power feed. And I know I said orange should be used for foreign current, but they're also quite often used for safety signals or e-stops. Now here I have some common types of cable. And apart from these, we also have of course individual wires that we use to wire up our control cabinets. But these three cables are good types to have on hand, basically building any type of machine in your home workshop. And this is just a common regular control wire. It's designated as, let me see if I can show you here, there, 5Y0.75. And that means 5 total conductors, the 5, and of the 5, 1 is ground, that's the G, and they have a cross-sectional area of 0.75 millimeters. And these cables can be used for basically all external signals in any machine, and also for power feed. For power feed, you of course have to be careful that the cross-sectional area can handle the power you want to run from them. But they can be used for motors, switches, sensors, whatever. Important to note is that since this cable is unshielded, it can be, and I really want to emphasize, it can be more susceptible to noise. Now, if you have proper grounding and proper cable management, this shouldn't be too much of a problem. And by proper grounding and proper cable management, I mean that all the metallic parts of your machine should be connected to a star ground or a central ground bar. Such as, now it's really dark, but this bar here. And of course the entire back plane of my cabinet is grounded as well. And of course also here. And also here. And that also means that signal wires and power wires should be separated by a certain distance, preferably with a metallic wall in between, if they have to run next to each other, or only cross each other at a distance and at right angles. And I will explain why that is important in a little bit. Now, this cable is a fancier version of this one. This one is called a chain flex cable. And that means that both the housings and the conductors are designed to be bent, as inside a cable chain on a CNC machine. The individual strands of copper inside this wire are finer to allow bending many times without breaking. This one would work fine in a cable chain for, let's say, intermittent operation, but in a CNC machine where the axis moves all the time, a proper chain flex cable is to prefer. Otherwise, you will need to replace this sooner or later. But otherwise, they're the same. Like I said, it's a chain flex cable 5Y 1.0, which is 5 conductors, 1 ground of 1.0 millimeter cross-sectional area. And if you want to look it up, all of these other numbers can tell you how the working temperature is, what the maximum voltage is, what type of material it is, everything you want. Now, this is, well, it can be good to have on hand, but it would be quite expensive. This is a shielded signal wire. And these are used for interfacing sensors and switches where there's high risk of electromagnetic interference. That took a couple of times to say, I'll be honest. And what's important to know is that if you have a common shielded cable, I was always taught that the shield should only be attached to one end to not create any unnecessary ground loops, which might actually cause more problems than they solve. Now, some schools of thought say you should attach them at both ends, but if you have separate power supplies in each end, I would still suggest you only attach it to one end, and if you want to learn why, you will need to study some electrical engineering. But these will suppress noise quite well. There are also versions of shielded cable that have 2 shields, an inner and an outer. And in that case, you will attach one shield in one end and the other in the other end. So what is noise and why is it a problem? Well, easily explained. Any electrical conductor has a magnetic field around it. And the more current, the more power that flows through the wire, the bigger and stronger the magnetic field is. And that means that if we have a high current wire over here, feeding an AC motor or a big servo, and we have our signal wire over here that interfaces with either digital or analog signals, then the magnetic field from the power wire would envelop the low current signal wire. And this magnetic field would cause a current to flow through the signal wire, And this current in turn would cause a voltage to flow, and this voltage would then of course trigger the input or disrupt the signals. And that is what happens whenever you have noise or interference problems. And this is also why you should separate signal and power wires. And the higher power you use on the power cable and the lower voltage you use on the signal wire, the further distance you need between them, or better shielding. Now in heavy industry where I work, 24 volt is the standard for signal wires. And that is because to induce a voltage of 24 volts in this wire, you would need really high power on this cable. So within industry, it's more common that analog signals are distorted. So if you're using 0 to 10 volt signaling, it might be half a volt off because of the interference. And in that case, it's also more preferable to use 4 to 20 milliamp signals instead. And that eliminates most problems with interference. Another way to eliminate interference or noise is of course filtering the signals. So what is a filter in this context? Well, basically it's a capacitor. And if you don't know what a capacitor is and want me to explain it, leave it down in the comments and I'll consider it, or you could just Google it. There are people out there that are a lot more knowledgeable than me and can explain it better. Now I want to end this on one final important note, and that is PE, protective earth. And that is, like I said a minute ago, the yellow and green cable in all your both household electricity and electrical cabinets. And that should never and must not be confused with signal ground or neutral. Now, protective earth is there to basically ground any metal part of your machine in case of a short circuit or a cable break. Otherwise, metal parts of your machine might be conductive. They might be at 230 or 400 volts AC without you knowing, and if you touch them, you could die. But if you have a ground wire attached, either your ground fault circuit in your house would break, or the mini circuit breaker feeding that current would turn off. And of course, worst case scenario, you might destroy some electronics, but you wouldn't be at any risk of electrocution. Now, signal ground, that is only a 0 volt reference for our control electronics. And that might be ground for servos or DC motors as well in power circuits, but still it's not the same as protective earth. And especially if we're talking low voltage systems, like my Arduino system that uses 5 volt. Now, if I were to hook up the signal ground to the star ground, there is quite a possibility of actually destroying the electronics because of parasitic currents. So keep your protective earth and your signal ground or neutral separated. This video was a bit shorter, but I still think I covered all the basics and most of the important things to remember if you're building your own machine. Or even if you're building a machine for someone else. Now, if you like what you're seeing, you know what to do. Like, comment, subscribe. All the details will of course be down in the description. And if you have any questions or suggestions, leave it down in the comments or send me an email. Till next time.